All right, welcome to The Explainer. Today, we are diving deep into Apache Spark. You've probably heard the name. It's the incredible technology that has basically become the powerhouse behind all of modern big data processing.
So let's kick things off with a huge problem. It's a problem that pretty much every company, scientist, and developer on the planet is facing. We are creating these mountains of data every single day. So the real question is, how do you actually sift through all of that without getting buried alive?
The old way of processing data was kind of like having a single, really talented chef in a kitchen, but they're trying to cook for a 1,000-person wedding. Sure, they'll get the job done, eventually, but it's one dish at a time, it's painfully slow, and they are just completely overwhelmed.
And that is where Apache Spark completely changes the game. It's what we call a distributed computing system. So, sticking with our kitchen analogy, Spark isn't just one chef. Oh no, it's a massive, supercharged, state-of-the-art kitchen with a whole team of chefs all working on different parts of the meal at the same time. It's coordinated, it's parallel, and it is incredibly fast. Okay, so let's get into it. What exactly makes this supercharged data kitchen so much better than the old way of doing things?
Well, it really all boils down to three key things. First, and this is the big one, speed. We're talking up to 100 times faster than the older systems. Second, it's just so flexible. It's not a one-trick pony. It can handle giant batches of old data, live streaming data, complex machine learning, you name it. And finally, it's actually pretty easy to use. It has nice, clean interfaces for all the programming languages developers already love.
So, how does this thing actually work? Let's pop the hood and take a look at the moving parts that make this engine so darn powerful.
To get Spark, you just have to meet the kitchen crew. First up, you've got the driver program. That's your head chef, the mastermind who comes up with the entire plan. Then there's the cluster manager, who's like the restaurant manager, making sure every chef has a station and the resources they need. The executors, those are your line cooks, the dozens or even thousands of workers actually chopping the vegetables and cooking the food. And finally, you have RDDs. Think of these as magical cutting boards. They not only distribute the ingredients, but if one of the cooks messes up, the board remembers exactly how to remake that ingredient instantly so the whole meal isn't ruined. It's brilliant.
So here's how that all comes together. The head chef defines the job. Spark looks at it and creates the most efficient plan of attack possible. Then, that plan gets broken down into little tasks and handed out to all the line cooks. They all work at the same time, in parallel. And once they're done, all their little pieces are gathered up and presented as one final, perfect dish.
So we know Spark is fast, we know it's efficient, but how does it really stack up against what came before it? Specifically, the big name that used to rule the space, Hadoop MapReduce.
This right here. This is the single biggest, most game-changing difference. The old system, MapReduce, had to stop and write everything down to a slow, physical hard drive after every single step. Spark, on the other hand, does pretty much everything in the computer's super-fast RAM, or system memory. That one change, going from slow disk to lightning-fast memory, is the secret sauce to its incredible speed.
And when you put them side by side, the difference is just crystal clear. MapReduce was mostly for one big job at a time. Spark handles that, plus real-time data. We already talked about the speed difference and the ease of use. But look, Spark even has machine learning built right in. It's just a more modern, more complete toolkit for today's world.
Okay, that's enough theory. It's great, but let's make this way more concrete. We're going to walk through a really simple but practical example of a Spark job, from beginning to end.
So, let's pretend we work for a huge online retailer. The boss comes to us with a simple request. We have a massive list of every sale we've ever made, and we need to find out the total sales revenue for each product category. Like electronics, groceries, fashion, and so on.
So here's a tiny little peek at our data. A transaction ID, the category, and how much was spent. Now I know what you're thinking, that's just 4 rows. But I want you to use your imagination here. Pretend this table doesn't have 4 rows, but 4 billion rows. That's the kind of scale where Spark just lives and breathes.
Now, you don't even have to be a programmer to understand the logic here. It's really intuitive. First, you set up the kitchen. You start a Spark session. Step 2, you load your ingredients. In this case, our giant transaction file. Step 3 is the real recipe. You tell Spark, hey, group everything by its category, and then just add up the amount for each one. And finally, you show off your beautiful dish and clean up the kitchen.
And boom, just like that. Behind the scenes, Spark's distributed engine does all the crazy heavy lifting, spreading that work across maybe thousands of machines, and it gives us this beautiful, clean, final answer. Electronics made $3,500, groceries $300, and so on. A massive calculation made to look easy.
All right, so after that quick tour of the Spark kitchen, what are the most important things to remember? And maybe a few pro tips to keep in your back pocket.
Because look, as powerful as Spark is, it's not total magic. You can still run into trouble. If you keep using the same ingredients over and over, you should tell Spark to cache them, to keep them handy. You also have to make sure the work is split up evenly. Otherwise, you'll have some line cooks sweating and others just standing around. And finally, don't try to bring the entire billion-person banquet back to the head chef's tiny office. You'll run out of room. Knowing these little things makes your kitchen run so much smoother.
So let's boil this all down. If you remember nothing else, remember this. The core idea of Spark? High-speed, distributed processing. How does it compare to the old stuff? It is way faster and way more flexible. And what's it for? It is perfect for pretty much any huge analytics, machine learning, or data streaming job you can dream up.
And that really leaves us with a final and I think a pretty exciting thought. When you have tools this powerful, tools that can answer incredibly complex questions across billions of data points in just a few minutes, well, the only real limit is our own imagination. The tech is here. So what problems are we going to solve next?